Sophia, and I just got finished with my run. I'm training for my first big marathon. While I was out, I was thinking about writing algebraic equations and expressions and that problem that I helped my friend Justin solve. Remember? He was the guy who was trying to determine where and when his friends were going to meet along a trail. If you haven't watched that video, I suggest you check it out before watching this. There are different ways to look at math problems and often many strategies to solve them. If you just use a few basic tools, you'll be off and running. So lace up your shoes and let's get another problem solved. The example involving Scott, Sean, and their trail run is a good example to work with. Originally, I used a line representing the trail to describe what was going on in the algebraic equation, and then we reviewed the equation. However, you could also use a table to compare the number of hours each person ran and the distance both are from checkpoint A. Often, you will use a table that looks like this for your problem. The heading of the 3 columns for this table are number of hours, Scott's distance from checkpoint A, and Sean's distance from checkpoint A. You should remember that Scott was traveling 4 miles per hour and Sean was traveling 7 miles per hour. When Sean started, he was at mile marker 1 and Scott was at mile marker 10. After 1 hour, Sean had traveled 7 miles and was at mile marker 8, and Scott had traveled 4 miles and was at mile marker 14. After 2 hours, Sean had traveled 14 miles and was at mile marker 15, and Scott had traveled 8 miles and was at mile marker 18. Finally, after the 3rd hour, Sean had traveled another 7 miles and Scott another 4, putting them both at the 22-mile marker. Tables like this will help you see relationships and find the solution. A second strategy involves using a graph to visualize the problem to determine the solution. For example, here the horizontal line represents the number of hours Scott and Sean have been running, and the vertical line represents their distance from checkpoint A. We can easily plot where both men are when Sean starts out. At the first hour, we plot 8 for Sean and 14 for Scott. At the second hour, we plot 15 for Sean and 18 for Scott. We can begin to see that both relationships are linear. Sean's progress is represented by a straight line, so is Scott's progress. This is because they are both traveling at a constant speed. The point where they intersect must be when Sean and Scott are at the same location at the same time. That's after 3 hours. Whether you use a table, graph, equation, or number line, the solution and conclusion are the same. 4h plus 10 equals 7h plus 1. 4 times 3 plus 10 equals 7 times 3 plus 1. 12 plus 10 equals 21 plus 1. It checks. 3 hours is when they will meet. They will both be 22 miles from checkpoint A. By representing our situation in multiple ways, we can see the connections between the situation and algebraic equations, graphs, and tables. Incorporating these methods into your approach to solving math problems will give you more ways to say, "That's another problem solved."